In level 2, we will be drawing more angles in standard position, but this time we'll not only be using degrees, we will also be doing it in radians. We will talk about coterminal angles, which are two angles that share a terminal side, so they're in the same position. There's positive coterminal angles and negative coterminal angles, and then we're also going to be converting from degrees to radians and radians to degrees. So looking at this first example, a 30-degree angle, we always start with the initial side on the positive x-axis, and then 30-degree angle would look something like that. This is in quadrant 1. In quadrant 1, the reference angle is the angle you started with, because that is the acute angle formed by the terminal side in the x-axis, so the reference angle is 30 degrees. A positive coterminal angle is making a full circle from your terminal side. So what I would do is I'd take the 30 degrees and add a full circle to it, or add 360 degrees, which would give me 390 degrees. And so that is an angle whose terminal side is in the exact same position as 30 degrees. If I made another full circle around, I'd land in the same spot. A negative coterminal angle I would find by subtracting 360 degrees. So I'm still making a full circle, but instead of going counterclockwise, I go clockwise. So I would do 30 degrees minus 360, and I would get negative 330 degrees. So that angle also is in the same position for the terminal side. So there are an infinite number of coterminal angles, but you might be asked to find the smallest positive or the smallest negative coterminal angle. Okay, and then converting to radians, the formula that you would use for a lot of these, everything on the unit circle, you're going to need to memorize them. But while we start out, we're going to use this formula. If you start with degrees and you're converting to radians, you're going to multiply by pi over 180. So 30 times pi over 180. I can kind of simplify this by dividing 30 and 180 both by 30. 30 divided by 30 is 1. 180 divided by 30 is 6. So I end up with pi over 6. So that is the equivalent radian measure of that angle. In the next example, negative 405 degrees, we always start with the initial side on the positive x-axis, and then I'm swinging down in the clockwise direction. I'm going to make a full circle, which is only 360, but then I have another 45 degrees to go. So if I make a full circle and then go another 45 degrees, I'm going to end up about right there. And that would be negative 405. And that landed in quadrant 4. The reference angle is the positive acute angle formed by the terminal side in the x-axis. So that would be 45 degrees. The smallest positive coterminal angle, if I take negative 405 and add 360, I'm at negative 45. So I need to add another 360. And negative 45 plus 360 gets me to 315. So 315 would be the smallest positive coterminal angle. For the negative coterminal angle, we want to find the negative angle that's closest to 0. So for that, we would just do negative 405 plus 360, which gets us to negative 45, and that would be our negative coterminal angle, negative 45. And then to convert negative 405 to radians, I multiply by pi over 180. And that comes out to negative 9 pi over 4. And in the last example, 180 degrees, that's one of our quadrantal angles. Its terminal side is on either the x or y axis. Its initial side here, terminal side on the negative x-axis. So that would be 180 degrees. It is not in a quadrant, it's on the x-axis. Its reference angle, it doesn't have one, or it would be 0 degrees because there's no acute angle formed by the terminal side and the x-axis, so it doesn't have a reference angle. Its positive coterminal angle, if we do 180 plus 360, we get 540 degrees. And the negative coterminal angle, if we did 180 minus 360, the first negative angle we would get would be negative 180. And the radian measure, 180 times pi over 180 is just pi. We are actually going to hold off on this shortcut for now. We'll talk about this later when we go more in depth into the unit circle and we really have it memorized. But all the angles that are on the unit circle, we do want to memorize them in radians. So that should be something that we begin to do really quickly. But for now, it's okay to just take your angle and multiply by pi over 180. So in this case, we would get 11 pi over 6. Multiplying 240 by pi over 180, you get 4 pi over 3. Negative 210 times pi over 180 is going to be negative 7 pi over 6. And 135 times pi over 180 is going to be 3 pi over 4. Again, the sooner you have the unit circle memorized, the easier this will be. We want to memorize that 330 is 11 pi over 6. We would memorize that 240 is 4 pi over 3. And if positive 210 is 7 pi over 6, then negative 210 is just negative 7 pi over 6. And then 135 is 3 pi over 4. So all of these angle measures in degrees and radians should be memorized eventually, which will make the converting a lot quicker and easier. We won't have to use the times pi over 180 formula. Converting from radians to degrees, we are going to multiply by 180 over pi. So 5 pi over 6 times 180 over pi. If you forget whether you want to do 180 over pi or pi over 180, remember that you want your pi's to cancel out. And then I could divide, to simplify 6 and 180. If I divide them both by 6, I get 1 and 30. And then 5 times 30 is 150 degrees. So for now, to draw the angle, it's okay to convert to degrees, which you're more familiar with. And we get about right here. Remember that this is 180. So that would be about 150 or 5 pi over 6. And that landed in quadrant 2. Now, the reference angle in degrees is 30, which is equivalent to pi over 6 in radians. So you always want, if you are given an angle in radians and you're asked for a reference angle, you would also give it in radians. Another way to think about how to find that reference angle, when I did it in degrees, I did 180 minus 150, which is 30. In radians, the same idea would instead be 180 is the same as pi minus 5 pi over 6. This is like 6 pi over 6 minus 5 pi over 6 is pi over 6. So that would be the reference angle right there, pi over 6. The positive coterminal angle, a full circle in radians is, if I go all the way around, that's 2 pi. So if I want a positive coterminal angle, I would take 5 pi over 6 and add 2 pi. But I need common denominators, so I would, instead of adding 2 pi, I'm going to multiply by 6 over 6 and add 12 pi over 6. And that gives me 17 pi over 6. So that would be my positive coterminal angle. And then for my negative coterminal angle, I would do 5 pi over 6 minus a full circle, or minus 2 pi. But instead of 2 pi, I want common denominators, so minus 12 pi over 6. And that gives us negative 7 pi over 6. And that would be my negative coterminal angle. Okay, and the next one, let's first convert to degrees. So 7 pi over 4 times 180 over pi gives us 315. And again, when you have your unit circle memorized, we won't have to do these using the conversion, we'll just have it memorized. So the initial side on the positive x-axis, and then that would be 7 pi over 4. It's in quadrant 4. The reference angle, if this is, the full circle is 2 pi, if we do 2 pi minus 7 pi over 4, to get common denominators, I would want to do 8 pi over 4 minus 7 pi over 4, and I get pi over 4 for the reference angle. The positive coterminal angle, I do 7 pi over 4 plus 2 pi, or plus 8 pi over 4, and that gives us 15 pi over 4. And for the negative coterminal angle, 7 pi over 4 minus a full circle, or minus 2 pi, would be minus 8 pi over 4, which is negative 1, or negative pi over 4. Okay, and then the last example, convert to degrees first, negative 3 pi over 2 times 180 over pi gives us negative 270. That's one of our quadrantal angles. Its terminal side is going to be on the y-axis, so the initial side is still on the positive x-axis. Since it's a negative angle, we swing down in the clockwise direction, and that brings us to right here. So that's negative 3 pi over 2. Its degree measure, negative 270. Quadrant, it's not in a quadrant because it's on an axis. It doesn't have a reference angle. Quadrantal angles don't have a reference angle. The positive coterminal angle, if I do negative 3 pi over 2 plus 2 pi plus a full circle, instead of 2 pi, I want common denominators, so I would do 4 pi over 2, and we get pi over 2. Negative coterminal angle, I do negative 3 pi over 2 minus 2 pi, or minus 4 pi over 2, and we get negative 7 pi over 2. Again, we're going to hold off on shortcuts when we're not that familiar with the unit circle yet. So for now, you can just multiply by 180 over pi for these. So pi over 6 times 180 over pi is going to be 30 degrees. 5 pi over 3 times 180 over pi is 300 degrees, and 3 pi over 4 times 180 over pi is going to be 135. Now again, the sooner you memorize the unit circle, the easier these will be. As you can see, pi over 6 is 30, 5 pi over 3 is 300, and 3 pi over 4 is 135. So memorizing all the angles on the unit circle will make your life so much easier.